All right. Hello. Thanks, everyone. How are you doing today? Today, I'm going to talk about NEBRA UPA. It's a ZK primitive. And I will first tell you what is NEBRA UPA. And then I will tell you what the heck we're doing with EigenLayer. And let's get started. First, here's my thesis. I know all of you are restaking fans, right? But we have to use other kind of primitives, which is ZK. And so here's my thesis. Proofs, some of them with their knowledge, will power the next 10 years of Ethereum. And these are the sort of a categorization of ZK in very different kind of capabilities, like powering Ethereum, right? Let me do a little bit of survey here. Please raise your hand if you heard at least three of this project. Okay, cool, we're good. I'm in my home crowd. I'm a little bit scared because people may ask me go out because I'm not talking about restaking. You can see the problem here is we do have a problem. So there is a vision, right? Basically, Ethereum is the settlement layer of the human civilization. And the ultimate form of the settlement is going to be like proofs, which means every single Ethereum block will only contain a single proof. And all the computations can settle a val zero-knowledge proof. But the problem right now here is that the proofs are damn expensive in terms of the gas cost you're spending, right? So I actually have a very moderate setting here. You can say I just list the gas price as a 20 GWA, and also just estimate a 2,000 ETH price, right? Even under these moderate assumptions, if you want to settle a gross 16 proof, you need 250K gas, which translates to $10 US. If you want to settle a Halo 2 KZG proof, you want roughly about $16 US. And if you want to settle a Stark proof, you want to $60 US. This is insane. How can we achieve proof singularity if we keep settling that expensive zero-knowledge proofs? And this is a famous quote from Vitalik. Do I want to pay $20 to add some privacy for my transaction to buy coffee? Probably not, right? Even Vitalik says so, right? So who else are going to using these super expensive ZK primitives if the cost is so high, right? So the question here is that how can we make ZKP on-chain settlement cheaper? And the answer is using ZK itself. It's kind of using magic, and we are constructing more magic. And that's why I introduced NEBRA UPA, which is a universal proof aggregator. So here is a high-level overview of NEBRA UPA. So we take multiple proofs, and most importantly, this proof coming from different circuits, right? Basically, some of them can come in from ZK ROP, some of them can come in from ZKML, some of them can come in from storage proof. And that's how you get economy of scale. And we take this multiple proof, and using NEBRA UPA, this magic box, doing a recursive proof, and aggregate them into a single proof. And we post the single proof on chain. And now you only need to pay the gas cost of verifying the single proof. And all the costs getting amortized. And more specifically, under the current setting, we're putting 32 proof in a single aggregated proof, right? So here is kind of a little bit overview of the NEBRA protocol, right? We have our on-chain contract part, which is deployed on Ethereum layer 1s and layer 2s. And we have an off-chain part, which have a coordinator and distributed prover. But from the high level, we achieve three goals of this protocol. First is permissionless. It's a smart contract. Everyone can use us. And secondly, it's censorship resistance. It's doing so via a very similar design to L2s. It's kind of like an inbox and forced inclusion design. And third, most importantly, we're progressive decentralized. That's very high level. And actually, using us is quite easy, right? So on the left-hand side is how you are verifying a zero-knowledge proof today. You can submit a proof and to your verifier contract. And instead of doing so, you simply just call our smart contract, and still the same verification interface, you can verify your proof, right? So next, let's talk about how fast is NEBRA. Right? That's the important part. Like, what's the trade-off here? So the trade-off here is that by using NEBRA, right, you're submitting your proof. Sort of you are waiting for the batches. And we kind of batch the proof together and submit a single aggregated proof. Right? So this is actually like not my idea. Like Vitalik, I mean, there is a kind of like a pope, right? He kind of envisioned that proof singularity, which is like in a single block, only contains a single proof. So this is like not too long ago, actually, and people thinking this is a pipe dream, right? So however, we actually built an extremely performance proof aggregation distributed system here, right? Let me talk a little bit about technical here, because if you talk about performance, it's like a trade-off space, right? So you have latency, you have throughput, and also you have like amount of resources you are using, right? So we build our NEBRA UPA backend in an eclectic way so that it can leveraging increasing amount of computational power you can use. And it's fully event-driven, pipeline, and distributed, right? So let's take a single trade-off point from the sample, right? So under our current internal testnet, if we set the latency to 2 minutes, we actually can aggregate like 250K proof per day, which roughly equals to like a 32 proofs per block, right? So it's actually extremely fast. And so to show you a little bit real data here, right? So you can see we actually pipelined like NEBRA UPA together with Ethereum's block production, right? I think you can see the method here, verify statin, is a verification function of our aggregated proof. Basically, we have NEBRA UPA running sideline with Ethereum. And we can settle a single proof per block, right? So I'm proud to say we're actually achieved proof singularity internally. So, okay, now, like, what's the heck? Like, why I'm here, right? What's that to do with restaking and eigenlayer? So it turns out to be, like, eigenlayer can help NEBRA, and NEBRA can help eigenlayer. There are a lot of things we can do here. So the first thing I'm proposing here is that we should be settling snarkified AVS proofs on NEBRA. Basically, for each single AVS, there are a limited amount of operators. And along the line, right, if you want to truly scale AVS, if you have like more and more operator node running a single AVS, the best way to scale computation and then let the computation verified on Ethereum is putting the AVS proof into a single like a snark proof and settled on chain. And now, like eigenlayer need to pay like per block verification cost, right? It's basically like burning $20 per block, right? We can definitely help here because of cost effectiveness, because of the high speed, because of no latency, and also because we are going to be production ready Q1 2024. The next slide is actually like eigenlayer can help us as well, because as I mentioned, we have a progressive decentralized proving network roadmap, and we're very happy to try to using eigenlayer, using the AVS to build a decentralized prover network, so that here is what we get from using AVS. We get naiveless, we get cost effectiveness, and we also get better censorship resistance. The censorship resistance guarantee will be better than the current centralized L2s. Yeah, so this is the teamwork, this is our team, and also thanks for our advisors. And thank you, yeah. Shumo from NEBRA Labs.